Hello, we're going to be working on problem 1a using the slope formula to determine the y-intercept, which is expressed as 0, y in parentheses in coordinate form for the linear relationship. So, what is the slope formula? Let me highlight that for you. Here it is in yellow. So we're going to be using this to find the y-intercept. And then we'll be expressing the y-intercept in coordinate form, which will look something like this. So let's get started with step 1. Find the slope. Slope is equal to y2 minus y1 over x2 minus x1. We need to choose 2 points from the table. I'm going to choose the top 2. So I'm going to write that here now so it's clear. I have minus 2, minus 1, minus 1, and minus 2. I'm going to label the first row 0.1, the second row 0.2. With that said, we know we have x1 and y1 here, x2 and y2. Now that we've set that up, we can simply substitute it into our formula. Let's do that now. y2 is negative 2. y1 is minus 1. x2 is negative 1. We're going to subtract x1, which is minus 2. Thus we have minus 2 minus a minus 1 is minus 2 plus 1. All that's divided by minus 1 plus 2. See how the two minuses become pluses? Next, we're going to minus 2 plus 1 is simply minus 1. Minus 1 plus 2 is going to be 1. Thus, we're left with negative 1. That is the slope. So I'm going to come up here and write slope equals negative 1. We're done with step 1. Step 2 is to choose any point and label it x1, y1. Well, we can use one of the points we have, or we can choose another one. It doesn't matter. Let's just select another point. We'll use this one here. We already have a point labeled correctly, so we're going to use that one. We'll use this one. With that said, choose any point and labeled x1, y1. We've done that already. Check. Let me highlight it for you so you see what we've already labeled. Point 1 has an x1 and a y1 value. Now we're going to set up the slope formula and substitute in the values. There we go. We found our slope. That was negative 1. So let's rewrite this so you see what we're doing. We're going to rewrite it y2 minus y1 over x2 minus x1. However, this time we're going to substitute in for m our slope value of -1. We're going to box in our y2 just so we remember that we're going to be solving for this y value. We're then going to be replacing x2 with the value 0. And then we're going to be going to the point that we chose, the x1 and the y1, and I'm going to circle that. I'm going to substitute into those. So we have x1 as -2. So that's -2. We have y1 as -1. Why are we choosing x2 to be 0 and solving for y? Well, remember the point of this exercise is to determine the y-intercept. Now, the y-intercept is when x is 0 and y crosses the axis, y-axis somewhere. So this is the point where the line crosses the y-axis. This is what we're solving for. We don't know this yet, but we will because we have one equation with only one unknown. That is y2. Everything else has a value. M is -1, x is 0, x2 is 0, x1 is -2, y1 is -1. We only have one thing that we don't know, and that's y2. We're going to solve for that. Let's work this out. -1 equals y2 minus a -1, all divided by 0 minus a -2. Let's simplify that. y2 plus 1. Minus and a minus is a positive. 0 minus a -2 is +2. y2 plus 1 can't be simplified, that's all we can do. Divided by 0 plus 2, that can be simplified. Let's do y sub 2 plus 1 over 2. So let's bring this all together now. We have our -1 here, and we have this on the other side of the equal sign. So I'm going to bring them together. -1 equals y sub 2 plus 1 over 2. Now it's just a matter of solving. We're going to work with our denominator first. We're going to get rid of the 2 by turning it into a number 1. How are we going to do that? Let me show you. We have an equal sign right here, and it's like an imaginary line. Whatever we do on this side of the equal sign, we also have to do on the other side to be fair. So, in order to turn this 2 in the denominator into a 1, we're going to multiply the numerator times 2. But because we did it on the right side, because we did it over here, we need to do it over here. So I'm going to multiply it times 2. Now this is where the magic of math happens. We have 2 times a -1 is -2. And then we have y sub 2 plus 1. And I'm going to put that all in parentheses because when we bring that 2 up, it's going to have to be multiplied times everything. All over 2. I'm going to move the 2 over just a bit and extend the line. So now 2 is below 2. When you have 2 divided by 2 is equal to 1. So here we go. -2 2 plus 1. Remember, we have an equal sign. Now, how do we get y sub 2 by itself? Well, we need to do the inverse operation of addition, which is subtraction. So we're going to subtract 1 on both sides of the equation. And just so you know what we're doing here, we're adding -1 to both sides. And this line I've drawn here is not divide in this case. It's just a line so I can do my addition problem with one below the other one. It's just a shorthand notation to help me keep track of my numbers. So here we go. That equals 0, and -2 plus -1 is -3. Where are we at now? Extending this down, we have -3 equals y sub 2. I don't like to see -3 before my y's, so I'm just going to flip these. Y sub 2 equals -3. And I can do that now, because y sub 2 is by itself. So we found the value of y2 when, remember, x of 2 is 0. So with that said, we know the coordinate form is 0, comma, -3. This is the y-intercept. If you were to draw a graph, and we went up 3 points, 2, 3, that point would be right here. Now we also know something else. We know the slope, remember? The slope was -1. Remember that? So if we draw a line with a slope of -1, that means we come down 1 and go over 1. That'll be a point. Not sure what's going on here. That's a point. Come down 1, go over 1. Okay. Connect these points. The line's going to look something like that. So this point right there is 0. Oh, I'm sorry. Messed up. -3. I was doing +3. So we need to go down 3. 1, 2, 3. Then our point. And then if we use a negative slope, we're going to go down 1, over 1. So down 1, over 1, a point. And if we go down 1 from here and over 1, we'll have another point. You can start to see that line starting to form. So it will look something like that. So that's what our points would look like, and you'll see that some of these other points would tend to match up. In fact, one of the points in the chart is actually 0, -3, the y-intercept. Another one is 1, -4. Do we have that? Did we find that? How far did we go down here? 1, 2, 3, 4, and we're over 1. So 1, -4. Yep. Seems to match up fine. What's the next step in our process? We've done step 1. Find the slope, which was -1. We chose a point and labeled it x1, y1. We've circled that in green here. We've set up the slope formula. We boxed in the y2. That's right there boxed. We substituted in the formula 0 for x2, and we solved for y2. So that's still true. Here was our 0 value. And here's what we were solving for. Substituting values for x1 and y1, we did. We used that, -1 and -2 from up here, remember? What's next on our list? Step 4. It says solve for y2. Write in y-intercept coordinate form and the equation in slope-intercept form. Well, we solved for y2 already. That was what we were up to this whole process here. We put in our values and we solved for y2. We ended up with y2 equaling -3. So we did this step, solve for y2. We wrote it the y-intercept in coordinate form. Here's our coordinate point, remember? 0, -3. So this is in coordinate form. And we still have yet to do the equation in slope-intercept form. Y equals mx plus b. Okay, so that's what we'll do now. Y equals mx plus b. Well, we know slope is equal to -1. We solved that at the beginning of the problem. What is b? Well, that's the y-intercept. Where did we intersect the y-axis? At -4. So in this case, b equals -4. We intercept right here. Let me highlight that so you see. Right there. That pink dot is the y-intercept, and it crosses the y-axis 4 steps down. You have to go down 1, 2, wait a second. It's not -4, it's -3. It crosses at -3. Count down 1, 2, and 3. Okay. Now that we have our values for m and b, we can substitute into the equation. We're going to leave y and x alone. We're going to write those again. y equals slope. What is the slope? It's -1. And then we're going to write our x, and then we're going to add our b. When you add a -3, you end up with y equals 1 minus 1x minus 3. So plus a minus is a minus. We don't need to write this first term here, this -1. We don't need to write the 1 coefficient in front of an x. All we need to write is y equals minus x minus 3. The 1 is understood that it's there. There's 1x, not 2, not 3, just 1. So we have minus x minus 3. So, thanks for your patience. We have now written it in slope intercept form. Why do we call it slope intercept form? Well, this form of the linear equation has a slope value, which is here in purple, and it also has a y-intercept value, which is in that orange. Slope, -1, intercept, -3 form of the linear equation. Let's see what our steps say. Are we done with all our work? Nope, we have one more step. We need to check it. Make sure that the formula we wrote down in all our math works out good. So what do we do? We substitute an x value into the equation we've written and see if the y value is correct. So we're going to just choose a point and see if we get something similar. If you look right there, we have a point 1, -4 in purple. Let's bring that down here to the bottom. -4. And we're going to test our equation we wrote with this point. We know the first term is an x value. We know the second term is a y value. And we know this point is along the line. We showed that here. This point is on the line, the yellow line. So if we substitute the x value, that's this right here, into the formula, we should come up with a value of -4. That's what we're going to test. That will tell you if our equation we wrote here is correct. So let's do that. Y equals minus x minus 3. We're going to take the x value that we have here, which is 1. Y equals -1. We substituted in 1 into the x, minus 3. What does that add up to be? -1 minus 3 is -4. Does that check out? It does. That tells us that we've done good math and our results are accurate. Not only have we verified that with some points and a graph, but we also have verified that algebraically by substituting back into the formula we created. We know a lot about this line now. We know its slope. We know it's negative. It's going down to left to right. And I think I'd like to do one last thing, and that is just label this line, give it its name. It's called y equals minus x minus 3. Okay? We know it's y-intercept. Eventually, as you guys advance in math, you'll also learn that this line crosses the x-axis. But that's for another day. That point is important too. That one I just marked here. Right now we're only studying y-intercepts, okay? Where the lines intercept the y-axis. So this is 25 minutes of talking. Thank you for being patient. That was problem 1A. 1B will be a little quicker.